Okay, a couple of examples dealing with using the algebraic process here. So, and if this question looks familiar, yes, it is. It's the exact same question we did geometrically using our parallelogram law or triangle law. So now I'm going to do it algebraically. Same thing. I want you to draw a diagram to start with or give yourself a sketch. So this time I am going to orient the vectors such that one is either along the x-axis or horizontal or vertical, and it doesn't matter. And because this question doesn't specify the orientation, it just says that one is 30 degrees to the other, I'm going to put my u vector here, and its magnitude is 10 with an angle of 30 degrees, and I'm going to say this is my v vector, and I'm going to make sure it's oriented on the x-axis. Because when you use the algebraic process, what we're going to do with that algebraic process is we're going to superimpose a Cartesian plane, so an xy axis on it. And if something's on the x or y axes, it sure makes life a lot easier, and I'll show you the why. So algebraically, we need to convert these geometric vectors, pictures, into an algebraic equation, and we want to add them together because that's what resultant means. So over the side here, my resultant is the vector u plus v. So that's the goal. We're finding the resultant. Resultant occurs from either addition or subtraction, and in this case, determine the resultant is indicating addition. So I'm going to set it up, the u vector, the v vector. I'm going to set up similar to what you saw with elimination and substitution back in grade 10. So now I just got to convert the u vector and v vector into coordinates, and I'm going to use the unit vector form. You can use coordinate, it doesn't matter, it's the same, it'll look the same except for the notation. So the u vector, talked about yesterday, it's the magnitude of the vector, 10, and cos of the angle, so cos 30, and that's in the I direction. So I just found the x component here for the u vector, and that's what it is. So here's my x component, plus, because I go up. So road map here, if you look at the diagram here, the road map, the magic pen here. So I found my x component, how far I had to go across. Now I have to find the y component, how much I have to go up in this case. So that's why it's addition. So plus magnitude of the vector, sine of the angle, sine 30j. All right, now the v vector. Got to find its x component. So that was the y. So find its x component. So I'm going to go 5. And I don't need an angle. It is an angle of 0, but it's 5 units along the x-axis. So I can just say 5i plus, because it doesn't leave the x-axis, there's a 0j component. I don't have to go up. So the unit vector approach, remember, is like a road map system. So it's telling you how far you go left or right, and then how far you're going up and down. So there we go. So now we just have to add these together. Again, you don't have a calculator. So the resultant would be 10 cos 30 plus 5i, and again, I'm adding the vectors together, plus 10 sine 30, and for argument's sake, I'm going to put the 0 in, but it's not necessary. So there's the resultant. All done. Much, much more efficient than doing it geometrically. So that is our resultant. Now we need to find magnitude, and we need to find direction to finish this question off. So the magnitude of the resultant is the square root of the x component, so 10 cos 30 plus 5, and that's got to be squared, plus 10 sine 30 squared. So there's my magnitude. You don't have a calculator, so you don't have to take it any further. That's all I'm looking for. Need to find the angle, tan inverse. And remember, it is the y component divided by x component. So 10 sine 30 divided by 10 cos 30 plus 5. Don't have a calculator. That's as far as it goes. So you do need to have a therefore statement for me. So therefore, our vector is magnitude of r above in the direction And this is where it takes a little bit of logic thinking here. I want you to tell me which direction it is, so I'll explain how that works. So I'm going back to the original vector. 10 cos 30 plus 5. I know that's going to result in a positive value. So that means I moved to the right. 10 sine 30 will also result in a positive value. So that's going to be a positive, which means I moved up. So when I translate that to a direction down below here, that means that I went east, or you can put right, depending on what system you're using, theta, which is defined above, and north, or up. So I'll put both. I don't care whether you use right, left, up, down. Both of those are acceptable. So again, I'm just looking at process here. Can you go through and do this? And I'm not worried about the calculator because calculations, that's not part of this course. Can you apply vector concepts? So there you go. So if you go back and flip back through your note and compare how is this question geometrically compared to algebraically, that's the determining factor. And what you're going to find is most people are going to move to the algebraic process. Similarly, this question should look the same. Okay, and yes, it is the exact same question. I'm just going to do it algebraically. So, if I recall, I think I had this as vector u, this is vector v, and this is vector w. So, determine the resultant. Well, and I'm going to put it down here. My resultant vector is equal to 3u minus 2v plus 5w. All right. My u vector, so I'm going to list them all down below, or I guess I can do it over the side here. So my u vector is equal to, so again, looking at the u vector, if I superimpose a xy axes on all of them, and that's what we're doing, a bunch of mini xy axes. That's not the best one, but that's all right. Okay, how would you describe the u vector? Well, I have to go across one unit. So it's going to, and I'll put the 1 in, you don't need that. So 1i, and then I don't go up or down, so it's plus 0j. And yes, you do need, I'm going to ask you to put this in for the first little bit, okay? Minus 2v. Okay, so minus 2v. So I need to take the v vector, and I need to double its value because it has the negative 2 there. All right. So I'm not going to worry about the negative sign. I'm just going to multiply it by 2 because I'm going to do the subtraction. So how do I do the v vector? Starting at the origin, I go to the right. So that's 2 units. Now I got to double it. So it's actually 4i. And then from that point, I have to go down. Now that's subtraction because it's negative on the y-axis. So minus down 2, I've got to double it, so it's actually 4j. And now I'm on to my plus 5w. So looking at my w, I don't move left or right here, so it is a value of 0i. So this is the plus 5w. And I am going down 1 unit. Got to multiply that by 5, so it's going to be minus because I'm heading down, and it'll be 5j. If we add those up, or do the operations, we're going to end up with our resultant. So because I've done all the multiplying here, all I have to do is worry about the signs when I'm collecting or adding my like terms. So going through, I'm going to add up the first column. So it's going to be 1 take away 4 plus 0. So 1 take away 4 plus 0 gives me negative 3i. And doing the j column, I'm going to have 0 subtract negative 4, which would be 4, plus negative 5. So I end up with negative 1j, or just negative j. All right, so there we go. So we end up with negative 3i minus 1j. now I got to make a bit of a correction here because I was looking at it and I'm thinking back to the previous answer, and most of you are probably screaming, why did you not do 3u? And the answer was because I'm testing you to see if you know what's going on. That should have been a 3u, so what I have to do is I have to triple all those values there. So I do apologize, but there's only one correction to make, thankfully. This should have been 3i, which now changes that answer. So it becomes 3 take away our 4. Yep, 3 take away the 4. So it becomes negative 1. Now you're really starting to laugh because that u vector is actually 2 units long, so that should be a 6. I'm going to get there eventually. All right, talking to myself too much, that's the problem here. Okay, let's try that again. So again, that u vector, my mistake was it's 2 units long. I need to multiply it by 3. So that gives me 6. So now I know what I'm doing. We're back on track. 6 take away 4, so now it's 2i, and now this matches up with the previous answer. So, finishing the question off, magnitude of r equals square root of the x component squared plus the y component squared, so that would give me a square root of 5 units. My angle, theta, and when you do algebraic method, it is always tan inverse of the y component over the x component. And again, if you look at your answer from the previous one, it's the same answer now. So, therefore, vector r is root 5 units. And the direction, and again, you can choose whether it's, I always go northeast, southwest, but you can use right, left. Same marks. I'm not going to dock you. It doesn't matter which system you use. So I'm looking again up here. I know I'm positive on the x-axis, which means I move to the right or east. I'm negative with my y component, so that means I moved down or south. So I'm going to say I moved east, and then I rotated theta degrees towards the south. And there we go. Again, no calculator required. I'm just looking for that process. I have one more example on why. If you're not sold on the algebraic method yet, I've got one more example. Hopefully that will be the final selling point.